Why should the forward direction be used for oxidation reactions in the first step? How do the scanning directions differ for oxidation and reduction reactions, and what determines whether a material should be scanned in the forward or reverse direction? Can Davis Zurins manufacture solid-state sodium-ion batteries made from seawater in Latvia? Why is this approach commonly used for cathode materials? What challenges arise when setting parameters for systems with poor reversibility, and why might a closed-loop voltammetry curve be difficult to obtain in these cases? What steps should be taken when a system with poor reversibility fails to produce a closed-loop curve using the previous method? How should the initial settings be adjusted for systems with poor reversibility, especially when considering the first step of the reaction? How can the type of reaction in the first step, reduction or oxidation, influence the setting of the initial voltage? Why is the determination of high or low potential important based on the nature of the first step? What factors influence the scanning direction in this context, and how is it determined based on the first step of the reaction? How does the setting mode, which is often used for anode materials, differ from the method used for cathode materials? What happens during the measurement of anode materials that leads to a period of rapid discharge at the beginning of the measurement, and what impact does this have on the overall data collection? What is cyclic voltammetry, CV, and why is it considered a commonly used method for transient electrochemical measurements? What role does CV play in studying dynamic potentials, and why is it important for understanding electrode reaction kinetics, reaction mechanisms, and reversibility? How are redox reaction processes characterized by CV curves as seen in the example of the HCSBB MEN and PBM electrodes? How many pairs of redox peaks are present for the HCSBB MEN electrode, and what are their corresponding voltage values? What do the voltage values of 3.69/3.51 V and 3.46/3.16 V represent in terms of the redox pairs for the HCSBB MEN electrode? And what do these pairs correspond to in terms of MN3/MNI MNHS and Fe-CN63/Fe-CN64 Fe-CNLS? How do the redox peaks help illustrate the reversible intercalation/deintercalation of Na ions in HCSBB MEN electrode? Why is the MNHS electric pair at high pressure described as being highly reversible and active, and what does this imply for the overall electrochemical performance of the HCSBB MEN electrode? What is meant by fast reaction kinetics and voltage stability in the context of the HCSBB MEN electrode, and how is this demonstrated by the low voltage polarization 180 MV and 300 MV between the two redox pairs? How do the results for the PBM electrode compare to those of the HCSBB MEN electrode in terms of redox pairs, and what are the corresponding voltage values for the PBM electrode?